Hello and welcome. We are about to begin our Lab K. This lab is on Kafka and KSQLDB. And we're going to just go through each of these questions one by one. We've got 8 of them to do. Let's get started. Number 1 says, write a drill query to display the ATM transactions that ended in an error status. Show all columns and sort output so the newest errors are first. All right, so first and foremost, I'm going to need to launch the ATM data stream. So I go over here to Jupyter and I've got my ATM example. I'm going to fire this baby off and now it's producing some ATM withdrawals. Now I did modify this earlier. I got to fix this. The error rate's way too high. We don't want that many errors. That's good. Let me just restart it. There we go. It's nice to have errors, but I don't want 75% errors. I'd like it to start spitting out data, and maybe 1 out of every 20 is an error. That's fine. All right, let's go back here and answer the question now. So here we are in drill, and I need to make sure that I've got my Kafka set up right. And I've got it pointed at the broker, and I've got it set to earliest, and I got the group ID to be a wildcard. That's important. It's having that group ID be a wildcard. And now I should be able to query it in Kafka. I should be able to say, select all from Kafka ATM. Like that, just to get some stuff. Step 2 in drill is, can you see something? Whether you're using drill or Trino or any of that stuff, it's all the same. You want to just make sure that, the storage provider works first. So it looks like I got a bunch of stuff in here. I got a bunch of OKs, but there's some errors in here. If I look, there's definitely errors in there. So let's go back and now try to answer the question now that we know that at least it works. And let's see, it says, only the ATM transactions that ended in errors and sort by newest errors first. All right. Back we go. Status equals error. That's step 1. I want the newest ones first, so I want to sort by timestamp in descending order. Or by timestamp in descending order. Okay, it doesn't like that. You got to be really careful with the column names. So it's probably got to be like this. Timestamp. And timestamp is probably a reserve word because it's pink. There we go. How's that look? There we go. Okay. There's the solution to the first one right there, staring you in the face. Pretty easy. Okay, let's try another one. Let's see what number 2 has in store for us. Right, I do a drill query to display the total amount withdrawn by user and do not include error transactions in the totals. Okay, so I want to get a sum of withdrawals by user without including errors. All right. Let's start here again, where status doesn't equal error. How's that for starters? Get that. Okay, it doesn't like that. This is why you're incremental about the changes that you make, because you don't want to introduce something that doesn't work. There we go. So these are all okay. I could have just said equals okay. It's the same as not error. All right, that's step 1. Step 2 is I want to group. Let me go back and see that again. I forgot my columns already. I want to group by user, and I want to sum the amount. Now that worries me, so I'm going to backtick that bad boy. as total withdrawn from Kafka, where that group by user. That should do it. Got a lot of anonymous in here now. I don't know if it's just not doing it right or what. So my hunch is that it's not picking the right thing. So I'm gonna alias. I'm gonna do an alias here. I'm gonna say ATM A, and then I'm gonna do a.user. I have a feeling it's like that's some other thing that I don't want to look at. It's like some drill thing. Now, this is a kind of the problem with SQL over anything is. There we go. See, now that looks right. And this is the number one reason why you never just want to trust, you query it and it's like, I just trust it. It's right. You don't want to do that, right? You want to be 100% confident that what you're doing is right. And so one way to do that is if I order this by total withdrawn, right? Let me go back here. And then I say order by, and then this total withdrawn. Let's see what we get here. IDA has 3,620 withdrawn. Okay, so we need to spot check one of these to make sure it's right. So I probably want to include a count in here. Let's do that. Let's go back here and do like, I don't know. Let's do like count. The rows as count of withdrawals. And IDA has 47 withdrawals, okay? So now let's go take a look at her withdrawals. Let's do this. Where status is not here and a.user is IDA. Now the data is still in motion, which is, this is like a little problematic, right? 47 withdrawals, 3870. Now what I would normally do if I was someone that really wanted to make sure this was right before I gave it to somebody else is I would take this data here and I would totally export it. Take this and I would export it and then put it in Excel and add it up and make sure it added up to the same number I was getting with the grouping. And then that way I would be confident that it was right. Make sure the count is right and the group is right. And then you know that you can trust the query. Okay. But as I had it before, this is the correct answer for number 2. I'll put it back in there. But it does bring up, how do you know your answer is right? Because before, when I just had user here without the A, right, I was getting these weird anonymous things. And that's obviously like the user login or some weird stuff like that. And that's not what I want. And so you shouldn't just look at this and say, like, well, it must be everybody choosing an anonymous ATM. You need to know that this does not pass the sniff test. Okay. And you need to fix it so that it does pass the sniff test, right? And then this version here does that. Okay. All right, that's number 2. Let's move on. I beat that poor horse. All right, so we have write a KSQL to create a stream named weblogs from the JSON keys in the weblogs Kafka topic. Make sure to set the timestamp property to the timestamp from the stream. Okay, so first things first, I got to turn weblogs on. I probably should turn ATMs off at this point. So let's go over to here, and this is still just churning out ATM withdrawals. Let's shut that down. Shut it down. Okay, let's clear the output while we're at it. Okay, and then let's go down to weblogs, right? And let's get, right now our max speed is 5 seconds and our min speed is 20 seconds. Let's kind of make this go a little faster. get some more logs in here. Let's do them every between 1 and 7 seconds. That's fine. And then it's going to give me some logs here, right? Username, timestamp, browser, OS. Yep, it's going to give me all the goods. Okay, so let's run that. And then boom, there you go. Hank just did something, and then Hank went here, and then he went there again. And then Abby went here. Okay, so we got some logs churning out. So let's go solve our KSQL problem. So first thing I need to do, I'm out here at the command line, is I need to log into KSQL, and it's docker compose exec KSQL DB command line, and then I'm going to run KSQL, and then I'm going to run it on the server, which the server runs on KSQL DB server on, I think it's 8088 is what it runs on. That should connect me to the server. There we go. And let's just do a show topics to see where the hell we're at. And you see there's a weblogs topic right there. And it's doing some stuff. Okay. So now we can try to answer the question, right? So it says, write a stream named weblogs from the JSON keys in the weblogs Kafka topic. So it might be useful to go look at this right here. I have URI, user, timestamp, browser, OS. Right? Those are my columns that are going to be in my table. So URI, user, timestamp, browser, OS. Let's do this here. Create stream. Zoom it in a whisker. Weblogs. Oh, I already forgot. URI. Oh, man. It sucks getting old. URI, user, timestamp, browser, OS. URI, user, timestamp. Bing it. Browser? OS? Right? That's part one with Kafka. Topic is, ooh, man. What was that Kafka topic? Mine's like weblogs. Weblogs. Kafka topic, weblogs. And then it's, I need my value format, right? Value format is JSON. And my timestamp is going to be the column timestamp. It's important to have a timestamp, or else your window command in the from clause will not work. Okay, made my stream. That looks good. I'm going to copy it because it looks like it's going to be the right solution. Okay, and then always, we want to, after we do that, we need to check to make sure that it did make what we wanted. Okay, and so we should probably at least do a show streams. And there's weblogs, right? Okay, that's number one. We probably should do describe stream or describe weblogs. I want to show you this. When you describe weblogs, you just get the structure. Okay, if you describe weblogs extended, you get the structure, and you also get all of the metadata, like what I actually typed, what the Kafka topic is, what the value format is, what the key is, what the timestamp is. Okay, and this is all good stuff. And I bet you I'm going to ask that you run a query on it or something, right? Let's just run a query first just to see that it works. So I should do, let's select star from web logs, emit changes to see everything. Okay, there we go. It's dumping wonderful data to our console as people hit our website, right? So you might be saying, well, how would you do this in real life? You would have a Kafka connector, right, that would run, or you could actually write it yourself that would just tail the weblog, and then at every row in the weblog it would ship to a Kafka topic. You could do it yourself. You could probably find a plugin to do it. Okay, not uncommon. So I got that going. That's good. Let's see what the next question involves. Write a KSQL statement with a persistent stream / table called homepage, which only displays visitors to the root of the website. It should display all the columns out from the stream. Okay, so I can do that. First, I'm going to write it. Then I'm going to write it as a persistent stream. I wouldn't try to write this as a persistent stream right away. My goal should be to make sure that the query's right before I try to persist it. I mean, come on, do some common sense, right? Why are these always Chrome and Win? That's really weird. That I don't know. Something doesn't look right because it shouldn't always be Chrome and. Oh, okay. Well, I got Safari in there now. I guess I was just hitting the jackpot with Chrome and Win, right? Okay. All right. Anyway, enough of that. Let's just do the query. So from weblogs, where URI is / emit changes. See, I should probably make sure that this works before I get all excited and try to persist it. That would be a pretty good thing to do. Okay. So it looks right to me. It's always the same URI, which is what I want, because these are people that are just going to the home page. Okay. And now let's do this. Let's say create stream homepage as, and then we want to say this. Okay. Now, when you create a stream this way, it's running in the background. So you need to know a couple of commands so that you understand how to manage this, right? So first of all, anything that you run in the background, whether you create a table as or create a stream as, is always going to be visible when you do show queries. And you'll see that there is a query here, right here, SAS homepage. What you want to look for is the following. Homepage, because that was the name of the stream I made, homepage. Okay, and this is because it's a query, and this is just some unique number that it generates, right? So, and I can see the query in here. See that? It shows it right there. Gives it to me right there. I can also do explain homepage. And that's not the name of the query, and that'll give me an error. I need to say SAS homepage, and in this case it's 81. And I will see if I find where I did it. Ooh, man, that's like far down, isn't it? Clear it so you can see it a little easier. Okay, so you get, this is the home, this is the schema, and this is how it gets processed. So that's what the describe does. And then you can also show queries, and you will see that now there's a query or show streams, and you'll see that there's a homepage stream. Remember, when you make a stream, it generates a new topic, right? So I can have like every time someone goes to the homepage, maybe I want to send them a text message, right? I can now write my Python code to listen to this topic, and I don't have to put a where clause somewhere in my Python to filter out the weblog hits that are not on the homepage. I can just use this homepage topic to do that. That's the advantage of writing stream processors. You know, they take one topic as an input and they yield another topic as an output. Okay. Anyway, so I can do that. I can also describe extended, right? Describe homepage. How about this? Does that work? I'm tired of typing describe. No, I got to type it all the way out. Ugh. Oh my God. Describe home page extended. There we go. Okay. And you can see how long it's been churning away here. You know, it started at this offset and it's right there. Now, if I do it again, see the offset went up because there's been more things are chewing away, right? And there's even a little bit of a lag in here that tells you things it hasn't processed yet through the query. Okay, so you get all the goods in here. Now, one other thing that I should show you is what if you want to stop that query, right? So if I do show queries, and maybe I want to stop this other one. These are ATM withdrawals, right? I can do terminate. Terminate. I must terminate your query. If you don't say it in Arnold voice, it doesn't work. Yeah, so that just gets rid of the query. It shuts it down. And if you want to start it back up again, you've got to recreate the stream with the query. Okay, that's the way it works. Okay. You can also pause a query. I think there's a way to just pause. Is there like a? There's like a. Let's see here. Define, undefined, terminate. I think there's a way to stop a query. Maybe not. Maybe not. Anyway, okay. So let's clear the screen. So where am I? I've got this query. I made this query. And we know it works. But I never really queried the query to see that it works. So I guess I could do that. Or maybe I did. I don't know. Select star from homepage. Emit changes. This will run a query on the stream. Funny. Okay. Now let's try to answer number 5. What's number 5 say? Number 5 says, write a KSQL statement to count operating system users in 60-second windows. After 60 seconds, the counter should reset and the counts should begin again. So I want to count users in 60-second windows, but I don't really care about homepage users. I just care about the operating system users. Okay, so let's do this here. So select user count from weblogs, group by user. Let's just do that first. Emit changes. Let's do that first. One Zeke. One Nancy. Maybe I should speed this up. I feel like I should make this go faster or else I'm going to be waiting a long time. I mean, I know I'm only 24 minutes into the homework, but you certainly don't want to sit around and watch data stream. So what I'm going to do is I'm going to go back to this. I'm going to change the min speed to 2 and the max speed to 1. So it's either going to be 1 or 2 seconds. That should speed it up. I'm going to stop it. And I'm going to restart it. Boom. There we go. Now it should go a lot faster. Boom. Boom. Okay, so now I'm not waiting as long. Yay. No one likes to wait a long time. Me included. Right? So let's go back and where were we? Let's go back here. Let's run it again. Okay, now hopefully it will go a little faster. There's Mike. There's Bob. There's Vibov. Hank. Chris. I might see. Oh, there's Bob again. 2 Bobs, 2 Chris's. Okay, it's counting. It's counting. Counting is good. Counting is very good. Okay, like that. Now let's add our windowing feature. So what did I ask again? I said 60-second windows. Oh, count operating systems users, not users. Hold on, I'm counting the wrong thing. This is going to be a lot faster because there's far less operating systems. OS, select OS, select group by OS. Yeah, it's going to be a lot faster. 1 Windows, 1 OS X, 2 OS X, 2 Windows, 3 Windows, 4 Windows, 5 Windows. Okay, got that. In 60-second windows. So here's how you do that. In the from clause, you can say window. And then in the parentheses, you can specify the size of the window. So here you specify what kind of window it is. And then in here you say size, 60 seconds. It's very expressive here. You can say 60 seconds. You can also say 1 minute. It's very expressive. And you can't say 1 minute. You can't say size 1 minute 30 seconds. I don't think that works. Okay. I guess we could try it, but I don't think that works. And then you got to specify the kind of window you want. Do you want a tumbling window? Do you want a shopping window? Or do you want a session window? And I'll talk about each of these in a minute. Let me just get it working. Tumbling window. See, I can't do the 1 minute 30 seconds, but I can say, I can do the math myself and say 90 seconds, right? There's no law that says I can't do that. Okay. I don't want to wait that long, so I'm going to do a minute. Okay, so what's happening now is it's tallying up the operating systems as we go along, and it will keep tallying them up until we hit 60 seconds. After we hit 60 seconds, it will reset the window for both values back to 1. So you just have to keep watching. And eventually, when we hit a minute, it'll just kind of reboot us and send us right back to square one. Okay, and this is really important for time-oriented data. See, we just went back to square one right here. This is really important for time-oriented data because if you don't specify a window, the counts don't make any sense, right? Why would you want to count something forever? So streaming really doesn't make a lot of sense. Streaming with aggregates doesn't really make a lot of sense unless you're counting it within a window, right? So imagine this. You want to figure out what the busiest hour of the busiest hour of the day is, right? So one way you can do this is if you count them in 1 hour windows, right? You will, and then do a max, right? If you take this, right? Imagine, I guess I could show you, right? So like if you take this and assume that these are hours instead of seconds, right? And I take this and I persist this as a table. Like if I say create table, I'll just call it, requests by OS I'll just call it requests hour. How about rec hour as this, right? Okay. And now it's running in the background, right? And if I say select star from rec hour, right? I'll get the same output that I just had. Okay. See that? I get the same output, but I also see the window, right? I see how the window moves. See that window start windowed, right? and then I see like, 1, 1, and then, 11, 12, 4, 5, and then it goes right back to 1 here. It goes right back to 1. See, and what's nice about this is you have timestamps that represent the windows, right? Let me start it again. I know we already answered the question, but it's good to explain how this works. You have the timestamps that start the windows, right? And you see how it's like when I ask the persistent table, it's like stored in there, right? So I could do something like this. I could say, give me the min. Did I even get a name to this thing? I probably didn't even give a name to it. What did I do here? Where's my table? Show the tables here. Show tables. And then drop table rec hour. She's gone. All right. Now what I'm going to do is I'm going to do this again. Right? I'm going to do this again because I want to put a name on this. I'm going to call this rec count. Okay? Because that way when I look at the table, I see a rec count here. Well, I don't see it because it's gone. But I can now say select rec count. Do that, and I can get the rec counts out. Right. So let me just do emit changes, limit 5. Okay. Now here's where it gets interesting, right? So I can now do this. So let's get the max. Let's do this again. Let's do a select star. And so I have my window start and my window end, right? So I can do this, select max rec count as highest count. And then I want the window start. And then I want to take that from rec hour. And I want to group by the window start. And then when I do this, I answer the question that I wanted, which is, boy, I'll tell you what. Start. Window start, right? Maybe I'm not doing it right. Let's see if I can get it in there. There you go. Chew on that. Maybe it just doesn't like it. Copy and paste for the rest of you. I think I can do this. Wonder why I can't do that. Hold on a second. Let's see what happens here. This shouldn't work. Use that column. Let me describe it. Describe rec count. No, describe rec hour. Oh, see, it's not in there. Those values are not in there, right? So I can't use those in another grouping. I was going to try and group by the window start to say what is the value in the highest window. I can certainly get that data and send it somewhere else and do that, though. I just can't do it in here. What I wanted to do is this. Let me do this. Let me do select everything from rec hour again. Select And from rec hour, and then I want to emit changes, right? See, and that, like, if you look, like, see, this one is the highest value in this hour. It was 27 right there, and then that the MAC was 14, and then it reset, and now the highest value for the MAC and this one is 6, and Windows is 11. Okay, now Mac 13 and 8, 13 and 9, 13 and 10, 13, 11, 14, 11, 14 and 12, 15 and 12, 16 and 12, 17 and 12, 18 and 12, 18 and 13, 19 and 13, 20 and 13, 21 and 13, 22 and 13, 23 and 13, 24 and 13, 25 and 13, 26 and 13, 27 and 13, 27 and 14, 28, 29, 30, 1. Now we're back to 1. See, that reset. Now we're back to 1 for Mac. Okay. So the window changed right here. The window changed. And as a result, I don't get that value in there. But it doesn't seem that I can use this column in here. But I bet you I get it back out. I wonder if I can drill it. Be very interesting to see if I can drill that. I know I'm kind of getting off mark, but it's all useful. So I'm going to go back here. This was what? It was rec count? Rec hour. Let's go over to drill. Okay, let's do select star from Kafka dot rec hour. See what that does. And it does not like that at all. Now this is not the name of the topic, right? So I got to find the topic name because only you can't query the tables. You got to query the topic. So let's show the topics and see what comes up. There's a topic called REQ hour, and it's capital. I wonder if the caps matters. Let's try that. See if that makes a difference. Yeah, it does. Okay, so I have a timestamp in here, right? And I do not have any information about the window, right? So this doesn't help either because I don't get data about the window, right? And that's really what I'm looking for is some kind of data that is friendly for the window, right? It helps me figure out where it sits in the window, and I don't get that. Okay. All right. Well, that didn't work. But you see I have this column over here that was in there, right? And then I have this column over here. And see, if you change things around like that, and don't because it's part of the same topic, right? I got to get rid of the topic. The topic's still there that goes underlying. Okay. Let's see where I'm at. I know I spent a lot of time on that little tangent. Okay, so I did this. All right. And it says, write a KSQL persistent stream or table called user query, which displays the count of user activity on the website within 1 minute session. So this is kind of like what I did before, but I want it to be persistent. So user activity in 1 minute sessions might look like this. So what does it mean to be in a session? A session means you're active for, you're inactive for like 60 minutes, right? So that I don't want to use the session window here. I still want to use probably the tumbling window here. A session window of 60 seconds means no activity for 60 seconds. And that's not what we're saying, okay? I don't want to list, and I guess I could show you that, but it would be reset the window when they're idle for 60 seconds. That's what a session window does. And that's not what we want here. We want to get an aggregation within a minute window. Okay, so that's going to look something like this. I'm going to say select user count star as user count from, this is going to come from web logs group by user, emit changes, and I'm going to get that, and now I get to throw it in a window. Web logs window tumbling size 60 seconds. Okay. And I got a mistake somewhere. I put a S on my window. No. Okay. Now, that window is pretty large, and I guess I could talk over that window to see what happens. But if anybody reaches a 2, there we go. Rose is at a 2. So now what you got to watch for is when Rose goes back to a 1. Right? That's what you got to watch for. Because then that means the tumbling window has reset. Okay, so let's hold on and see what happens. All these should be going back to 1. I guess we could look for Rose, for Carly, for L. Any of those should now go back to 1. Oh, I see Xavier in here. Xavier has a 1, has a 2, but now he has a 1. Okay, so it did reset. Okay. Excellent. So it does reset the window. Now let me show you what the session window does. If I change this to a window session, that means it won't reset the window until 60 seconds of inactivity have elapsed. Now that's probably not going to happen. Let's just go with 5 seconds. I don't think I need size on there. It just needs 5 seconds, right? So this means reset after 5 seconds of no activity. So, okay, we got a bunch of people in here. Okay, Bob tombstoned. That means Bob got reset. Okay. So let's see what happens to Bob again. Next time we see Bob, it should be a 1 because Bob was a 2. Maybe. Got to keep holding out for that Bob. It's definitely been 10 seconds. All these guys are going to be reset at some point. Let's see if we get Bob again. Mike. Hank just got tombstone. Hank's going to get reset next time we see Hank. I can't believe we haven't seen Bob again. What are the odds? I guess they're pretty good. Anyway, if you do see Bob again, he will be back to a 1 because it's been more than 10 seconds. Oh, there's Bob. He's up here. I missed him. He's right there. Yeah, and he was back to a 1. Okay, so that worked. So that's a session window. So again, that session means reset after 5 seconds of inactivity. It's a much different way of doing the aggregation. So what we really wanted here, even though I said the word session, we don't want to use a session window. We want to use a tumbling window. And let's just go back. Let's just do 60 seconds. Okay. And now I want to take this and I want to make a table out of it. Why a table? Because I'm aggregating, right? I need to store this somewhere. So let's call this create table user count as that. Okay. And I got to change this to size. I need size back in here because it's tumbling. Okay, now that's running in the background. Show queries. There it is. It's running in the background. User count. And if I show topics, there it is. User count. And because it's a topic, I now can go back to drill and query it. Or I could use Python or whatever. It's just a topic. And I can get some of the data in here, if there's any data in here. Got the user count, and I got the message key, which is the user. Okay. So let's go and take a look at the output here and see what we get. So if I do select from user count, oh, emit changes. Always that darn emit changes, right? There you go. Why is it so fast like that? It's because, remember, the table stores data. So, this is always gonna like start spitting out the past data and then also the current data as it goes through. I wish there was a way you could leverage these values in here. There must be a way you can do that. I just don't know what it is. Okay. All right. All right. Let's see where we're at now. So I did that. Write a statement to display users who have more than 1 pages of activity in a 1-minute window. Okay. So that's easy. Each one of these things that I see before me is a count of page of activities. So I can just say that where the better describe it, where the user count is bigger than a 1, right? So only when there's more than 1 do I want to count it, and then I can see it, right? And so this will give me those alerts within that current window that I'm in down here. Okay. Okay. So more than 1 pages of activity within a 1-minute window. Hey, let's see number 8. In Jupyter, write a program to subscribe to the home page topic generated by stream table in question 4. All right, the home page topic. And display the messages to the console. We could easily write these to Elasticsearch, but we don't do that in this lab. Maybe I will do it because, I don't know, maybe. I will at least show you how to do it. Okay, so let's get this done. So the easiest way to do this, by the way, is we're not getting into the Spark streaming. That's, we just run out of stuff to cover in this class. Can't cover everything. So I just am showing you the Kafka Consumer here. There's an example of a Kafka Consumer with plain old Python. And, you just really are just importing the consumer module from Kafka. And then you're connecting to your broker or to Zookeeper, but I'm just going to connect right to the broker. And then this is just going to list my topics and show you them, right? And then ask you to subscribe to a topic. So there's all the topics that I have on my thing. And that's which one do you want to subscribe to? And I'm going to subscribe to homepage. And then I am going to see data, as it comes in. See that? As it comes in. Okay. So this basic structure here is what you would need in code to consume a topic, right? And then what are you going to do with the topic after you consume it, right? Well, that's what's happening here, right? I'm just throwing it on the screen. But you could easily post this to a REST endpoint, right? You could post this to a REST endpoint. Like you can come down here and do requests, post, and then send that to Elastic as we did in the other examples, right? You could just send that baby over to Elastic. Or you can, put it somewhere else. You can write every 50 lines to a file and then write that file to S3 or MinIO, right? There are lots of ways you can take data in motion and turn it into data at rest, right? The way that we take data in motion and turn it into data at rest is we collect it and then write it. You don't write it one at a time unless unless it's conducive to that, like Elasticsearch or MongoDB would be a great example of that, right? Because each one of these would be a document, and you would write each document to that collection, right? So that would be a very appropriate method of doing that. Or same thing with even inserting this into Cassandra, right? Because you can do an insert statement for each of these in Cassandra, right? As a way to do it. So one at a time makes sense in those cases, but one at a time does not make sense in MinIO. So what you would do is you would have a counter. I'll show you what I mean. So I'm going to stop this and I'm going to make a counter. This counter is 0. And then max is, let's say, max count is 10. And then what you do is you do these, and then when you get your payload, right, you count. Add 1 to the count, and then you do something like this. If count equals max count, then it's time to spill it. You print, write this as a file to HDFS, right? And so what you can do this like with HDFS or S3, right? And the idea would be is you're waiting till you get to a really big file, like the block size in HDFS is 128 meg, right? So you don't want to be writing 5 meg files, right? And so you got to do some math, and then what you would do is you reset the count, right? And then you might print the count, print count, just for the hell of it, right? And then when you run it like this, and then I put in homepage again, right? Well, maybe we want to do something a little faster. Let's do web logs, right? Then we won't wait around as much, right? So you can have this run, and whoops, I got a mistake in here. Where did I screw up the count? Did I not just edit this? Where did I edit this? Oh, it's up here. Oh, it's counter, not count. Counter. Yeah. I guess I should just call it count because I got count everywhere else. And let's just put in web logs. Consistency is key in programming, right? And then you're going to start to see some stuff spit out, right? I assume web logs is going, right? It's got to be going. And you're going to start to see some stuff spit out, maybe not, someday, maybe never. Are we still pushing out web logs? Still running. I screw up, and I restart it and mess something up. Let's try it again. And we'll do web logs. There we go. See, now it's spilling away. 5, 6, 7, 8, 9, 10. Write this file to HDFS. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Write this file to HDFS. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's spilling over from memory to disk, right? There's actually Python libraries that you can use to do this as well. And it's something that pandas can do as well. So you could do something where you keep appending it to a Spark data frame and then writing that Spark data frame out, right? So it might look something like this. Okay, so step 1 would be, initialize my Spark session, right? And I'm going to go back here and grab my consumer code here. I'm going to grab my consumer code. And I don't need a list of topics. I just know what I'm going to subscribe to. It's that ATM. This is just Python code here. And I'm going to subscribe to the topic called web logs. And just to show you that this is working, I am just going to do this. Let me just do, boop. And I missed a quote there. And then I missed a consumer. I got to do import here. I got to go back here. And I need the this right here. I need that. put that right here. Okay, and now I should be able to run this. And why doesn't it run now? Consumer. And then, oh, I didn't create the consumer. I left that piece of code out. So I missed this one. Right, I'll get it working. I'll show you what I'm talking about. Okay, so now this works, right? Shows messages, wonderful. So now here's how you integrate something like this with Spark, right? Lots of ways you can integrate it. So now what I want to do is I want to make a data frame out of this. So right here is where we get the payload, and the payload comes back in JSON format. See that? So you can easily make a data frame out of this. I guess I could just show you, right? You can do it like this. Spark create data frame, and then payload that. And then that should make a data frame out of it. Oh yeah, you know what? It's got to be a list of dictionaries. So I need to do this to say, take this one thing in the dictionary and make a list out of it. And then I get a data frame. See that? I can show that. Okay, so I can do this. I'm going to take this, right? So I get my payload, and then I go data frame is that. And then I need to take this data frame and append it to another data frame, right? So I wonder if I can just make an empty data frame and do that, right? So if I call this like df, right? I want to call it row. And then if I do df is Spark create data frame. And then I do df equals df union the row. I wonder if I can do that. And then let df show. Boom. Okay, that works. Now, why does it appear twice? Oh, because I put payload in there. Oh, wow. Okay, let's try it like this. Okay, it's missing required argument data. So I got to say data is empty. That. And now the columns probably don't match. Okay, can't infer schema. So I'm going to have to do this. I'm going to have to do schema. I got to make an empty data frame first, right? Before I can append anything. I could cheat, but that's for lamos. This is the problem with schemas. Time stamp browser OS. Okay, let's try that. This has to be a list. Okay, now what do I got? And for schema for empty data set, of course. So it's trying to infer the schema. So I have to give it a full Spark schema. But I guess one way I can fake it is I can always. Let me think about this. I did something like check to see if df is none, and then make it row. Like so, if I said, if df is none, right? First of all, I got to get rid of df. So if this is going to work, I know I'm kind of hacking here. I got to go del df. I got to get rid of it. Okay, that's a Python thing. So I can say if df is none, print. Wow. Right. I just want to show you this. Okay. And it's going to say df is not defined. So if I guess I could set it to something. Like I can set df to empty string, right? And then say if df, or I could set it to none, right? None, right? Okay. And then what I could do is this: is I could say if df is none, then df is going to be the row, right? Else df is df dot union the row. And this gets around that first problem where it doesn't work, right? So if I run this, right, and then I do show df, df show, I get 1, right? If I run it again, I should get another one, right? And if I run it again, I get another one. It keeps unioning that same row in there, right, to build out the data frame because the first time through it wasn't there. This is okay in my for loop, right? If I take this and put it up here in my for loop right here, right, and then, get that payload and then add it to my data frame. And then as long as I come up here and say my data frame is none, by the time I'm done, let's suppose when I hit the max count, I just break to make it stop running. When I'm done, my DF should be full of stuff. Like, see, okay, there's my simple one, right? This is a bogus one I made. Now when I run this, if I did it right, big if, okay, 7, 8, 9, 10, write to file, and then I show, and then my data frame now has, see, look at that, it has all the events in it. Okay, so that works. Now what I want to do is I want to actually write it to the file, right? So this is actually easy, right? I can just do down here, instead of breaking out, I can do df.write, I don't know, CSV. I'll just do JSON. And then let's just write out home file, home Joyvian, I don't know, data sets, test, JSON. Just going to do that. And I want to do the mode append, so I can keep adding to the file, right? I want to keep adding to the file. And let's just run it. And I'm just going to put it, I guess let's do this. I'm going to put that right to file like that. There. And I can always hit keyboard interrupt to stop it, right? And so the first time through, it's going to make the data frame. The second time through, it's going to keep adding to the data frame. And then it's going to start dumping it to the file, right? Let's run this. Okay, and maybe it works, maybe it doesn't. It's funky. I think it's, let me just stop it and then hit restart that kernel. It could just be like, just picky. Probably run out of memory. Okay. Under that. Hopefully start showing me, it should print some output here at some point. I don't know what's going on. We can check for the file and see if the file's been made. Data sets, test JSON. I don't see it yet. I don't know what happened here. It's not, now it doesn't want to run. Oh, there we go. There we go. 789, write to file. Bump, bump, bump. 789, write to file. There it goes. Bump. Bump, 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 bump. Write to file. Now you can choose to write to the same file, or you can write, I would choose to write a different file every time. That way you don't run into any issues. I might choose to make this so that it does every 100 records and then writes those 100 records to a file. If I go over here and refresh, I will see that test JSON here. See that? And then here's all of the bits of that JSON file here. You see that? Oh, there. And that's just the Spark way. Is it's because I said append. going to put all these different ones in a different file. But that's pretty cool. And that's sort of how you would do that. You can write this out to S3 or MinIO or whatever you want to do. And then that way you can take this data that's in motion and you can now turn it into data at rest. Where did I go here? I'm in the wrong place, aren't I? No, I'm in the wrong place. Yeah. Yeah. So you can take this data in motion and conveniently turn it into data at rest. Now, one thing I'm kind of doing wrong, I think, maybe not. Yeah, it should be fine. But that's a good example of how to do that. And I'm going to stop it now. I'm going to hit Control Break. Okay. Keyboard interrupt. Yeah. So that's how you would take data in motion and turn it into data rest. Now, there's plenty of connectors out there that will do this for you, so you don't have to write the Python program yourself. This is in the world of Elasticsearch. This is kind of what Logstash and Beats do. Is they will do this for you. You just set the configuration up and run with it. You don't have to write the code yourself to do it. Anyway, I just wanted to show you how to do that because I think that's one piece that you sort of need to see. How to take this data in motion and dump it into a sink, make it data at rest. Usually, again, you're going to use a Kafka connector to do that. Okay, that's it for the homework. I think I answered all of them. Bye.